After completing this project, you'll know how to 3D model and print a coaster featuring a stunning Voronoi pattern. If you're only interested in 3D printing, you'll also have the option to purchase the file and skip straight to that step. We'll use a combination of AI tools, vector software, Autodesk Fusion, and PrusaSlicer. So let's dive into the workflow. I started the design by asking ChatGPT to generate a Voronoi pattern inside the circle. I made sure to mention that I plan to 3D print it, so the model wouldn't include walls that were too thin. While the initial image looked great, it included shadows and color gradients that would make tracing more difficult than necessary. To simplify edge detection, I asked for a black and white version instead. You'll see why that matters in the next steps. In this next step, we're using a free program called Inkscape. I'm simply dragging the image we generated with ChatGPT into the workspace. You could also go to File and Import to do the same thing. The goal here is to turn our image into an SVG pattern. To do that, go to Path and Trace Bitmap. On the right, you'll see the detection mode settings. Change it from brightness cutoff to edge detection. You'll notice the preview updates instantly. In my experience, edge detection works great for black and white images with sharp edges like the one we're using in this tutorial. Right now, we can't see anything behind the image because the detection mode hasn't been applied yet. Click Apply to generate the traced version. Once that's done, you can delete the original image. What's left is your pattern, ready to be saved as an SVG file. We're now inside Fusion, ready to continue with our sketch. Start by importing the SVG file from your computer. Stay organized so you can find your files quickly. Place the SVG on a horizontal construction plane to make sure it lays flat, just like it will when 3D printed. While not strictly necessary, I'll start by reorienting the view, since Fusion rotated the orientation when inserting the sketch. Then I'll confirm the insertion point, without closing the contextual sketch environment. Before moving on, we need to double-check the size. The diameter is too short, about 61 millimeters. The green color indicates a fixed constraint, so we'll remove it to make the sketch flexible. Then we'll use the sketch scale command to increase the size by 60%, bringing the diameter up to around 100 millimeters. The blue sketch color tells us the design isn't fully constrained. While full constraints are important in more complex projects with multiple parts, this is a simple one-part design. So to save time, I'll take a pragmatic approach and leave it unconstrained for now. By hitting E on the keyboard, you're doing two things at once: closing the contextual sketch environment and immediately opening the Extrude command. Select your pattern, set the extrusion distance to 3 mm if you're following my dimensions, and confirm the new body operation. Everything looks sweet and fine, but the quick measurement of the outer diameter shows it's a bit too thin. So I'll offset the face by an additional 1.474 mm to bring the total thickness to 3 mm. We can then double-check the updated thickness and confirm that the decimal math checks out. We're almost done in Fusion, but before we wrap up, let's add a few final touches to the 3D model we built from the initial sketch generated with ChatGPT. A chamfer is easy to 3D print and adds both elegance and strength. While 1 mm is a bit too much for a design this thin, 0.25 mm looks just right. For looks, let's apply two different appearances to the 3D model before printing. I don't have any yellow filament at home at the time of this recording, but I think it looks great, at least in the digital environment. That said, testing different colors virtually is quick and free, making it a great way to explore design ideas without wasting time or filament. Before we move on to export, let's make sure to save the latest version of the design. Exporting is easy, and here's a pro tip. Set up a structured folder system on your computer so you're not wasting time searching for files later. Head to the File drop-down menu in the top left corner and select Export. Change the file type to STL, then click Export. A link to your exported file will appear in the top right corner. With that done, we're ready to move into PrusaSlicer and set up the 3D print. Start by opening the File drop-down menu and import your STL file. Make sure to select the correct unit type, millimeters, which is the top choice in this case, since that's what we used in this project, not imperial units. Once imported, your object will appear centered on the virtual print bed. Right now, we only have one copy, but it's easy to add more within PrusaSlicer if you want to print multiple at once. When it comes to settings, you can dive deep and customize almost every detail, but the built-in presets are a great place to start. They balance different priorities like print quality, speed, and filament usage. Once you've selected your preset, click Slice Now to generate the G-code needed for 3D printing. You'll get useful data like estimated print time, filament consumption, and more. You can also simulate the print to preview how it will build up layer by layer. When you're satisfied, hit Export G-code and save it to a location of your choice. The 3D print came out great as always on my Prusa, which has served me flawlessly for years. Share your thoughts in the comments and check the video description for more info and affiliate links. Some may include discounts on products I recommend. See you in the next video.